Hi there. Today we're going to discuss indirect measurement, objectives and standards. Today we're going to learn how to solve problems involving indirect measurement using shadow reckoning and using surveying methods. How to use indirect measurements. Step 1. Set up a proportion of corresponding measurements. Be sure to use a variable for the unknown value. Step 2. Solve the proportion. Here's my first example. The lead statue of the Korean War Memorial in Washington, D.C. casts a 43.5-inch shadow. At the same time, a nearby tourist casts a 32-inch shadow. If the tourist is 64 inches tall, how tall is the lead statue? So here we have two triangles based on the heights and the shadows of two figures, our tourist and our statue. So what we're going to do is we're going to set up proportions of the corresponding measurements. So the height is going to correspond with the height of the tourist, and the shadow of the statue is going to correspond with the shadow of the tourist. So we're going to set up a proportion of the height of the statue, which we don't know what that is, so we're going to call it h, over the height of the tourist, which was 64 inches. And then we're going to set up the ratio of their shadows. So the height of the statue is 43.5 and the height of the gentleman or the tourist is 32 inches. Now that we have a proportion, all we have to do is cross multiply and solve. So we have 32 times h, and then we have 64 times 43.5. Now that we set up our cross products, all we have to do now is multiply. So 32 times h is 32h, and 64 times 43.5 is 2,784. All right, now our variable is h, and h is being multiplied by 32. So we're going to divide by 32 on both sides of the equation. So after we do that, our height of our lead statue is going to equal 87 inches tall. All right. So all we did here was we set up corresponding proportions of heights and shadows, and we solved using proportions. Okay, here's another example. Suppose the San Jacinto Monument in La Porte, Texas, casts a shadow of 285 feet. At the same time, a nearby tourist who is 5 feet tall casts a 2.5-foot shadow. How tall is the San Jacinto Monument? Okay, so if you need to draw pictures for this, that's perfectly fine. Let's just say that this is the monument right here. Okay, we don't know the height, so we're just going to call it h, but we know that the shadow that it costs is 285 feet. And then, we're just going to draw this right here. Now, we're going to talk about the tourists, and we're just going to make a little guy right here. And he is, how tall is he? He is 5 feet tall. So we're going to draw him 5 feet tall. So we're just going to go like this and say 5 feet tall. And his shadow is 2.5 feet. And then we're just going to finish off the little triangle here. All right. So now what we're going to do is set up our proportions and then solve them. So like I said, the heights correspond to the heights and the shadows correspond to the shadows. So we have an unknown height for the monument, 5 feet for the tourist. The shadows is 285 feet for the monument and 2.5 feet for the gentleman. Now all we have to do at this point is cross multiply and solve. So we have 2.5 times h, and then we have 5 times 285. Okay, so now that we have our cross products, now we can multiply. So we got 2.5h equaling 1,425. Our variable h is being multiplied by 2.5, so let's divide by 2.5 on both sides. Okay, and when we get that, our missing height is going to equal 570 feet. So the monument is 570 feet. Here's another example that doesn't really have anything to deal with heights and shadows, but this is about the surveying methods when we're talking about using measurements within like landscape and stuff like that. So here in this example, triangle STU is similar to VQU. So what we have to do is we have to find our corresponding parts. So we know that this one right here, QU, corresponds to TU, and then QV corresponds to ST. All right, so all we have to do now is set up our corresponding parts. So, like I said before, QU corresponds to UT. So 16 over 10 is going to correspond to, we don't know what this is, so we're going to call it X. And over here it is 20. Okay, now we've got our proportion. Let's start cross multiplying. Um, so we have 10 times X, and then we have 16 times 20. So we have 10X equaling 320. Now our variable x is being multiplied by 10. So we're going to divide by 10 on both sides of the equation. And x is going to equal 32, oops, sorry guys, 32 meters. Okay, so we basically did the same thing as before. We just identified our corresponding parts, and then we set up a proportion and solved. All right, I got another one for you. In this figure, PQT corresponds to PRS. Now we're going to have to find the distance across the lake. So again, the hardest part is just identifying which parts correspond with what. So here we know that 12 corresponds with X, and we also know that QP is going to correspond with PR. So let's just set up our proportion here. So we know that TQ, which is 12, corresponds to RS, which is X. And then we know that QP, which is 25, corresponds with PR, which is 60. Perfect. So now let's just start with our cross multiplication, our cross product. So 25 times X, and then 12 times 60. Got our cross products, let's multiply. So 25x is going to equal 720. Now our variable x is being multiplied by 25. So let's divide by 25 on both sides of the equation. X is going to equal 28.8 meters. Okay. All right, so now I'm just going to move on to nested triangles. And all nested triangles are is just a triangle inside a triangle. So what we're going to have to do with nested triangles is we're going to have to separate the triangles and label all the parts. So you're going to have to make an additional drawing to separate the triangles. And then we're just going to solve it just the way that we normally did. We're going to set a proportion, and then we're going to solve the proportion. So here's my first example. So we basically have two triangles inside one of the triangles. So I have this triangle right here, And then I also have a big triangle up here. All right. So what we're going to have to do is we're going to have to separate the triangles, like I said. So we have a little triangle right here, and then we have a big triangle over here. And then it's very important that you just kind of label all the parts. So for our small triangle, it's 7.5, and this is 2.5. And these are all in centimeters. And the big triangle, so from here to here, is going to equal 30 centimeters by x centimeters. Now that we've labeled our similar figures, now it's just easy from this point. Let's set up our um, corresponding parts. So 2.5 corresponds with x, and 7.5 corresponds with 30. So now all we have to do is our cross products, multiply, and then solve. So 7.5 times x equals 2.5 times 30. All right, now we're going to start multiplying this out. So 7.5x equals 75. And then our variable x is being multiplied by 7.5. So let's divide by 7.5 on both sides. So x is going to equal 10 centimeters. Okay, again, I started off with a triangle within a triangle. I separated the two of them, labeled all my parts, and then I just cross multiplied and solved. I have another example for you, but this one's going to be a little tricky, only because they actually don't give you all of the parts. So I'm going to start off by separating the triangles. So I know I have a small one, which is EDF, this one right here. And then I have a big triangle, which is ECG. All right, so I'm going to label my parts. ED is 6, and then DF is 7. I know that my CG is X. I don't know what that is. But the question now becomes, what is this whole side? They didn't give you the whole measurement like they did over here in our last example. We kind of have to figure it out, and all we have to do is add. So 6 plus 9, that equals 15. So now I have my two triangles with all the parts. So I can just start now by setting up my proportions. So 6 corresponds with 15, and 7 corresponds with x. Now let's start cross multiplying. 6 times x, and then 15 times 7. Okay, so now I'm just going to multiply. 6x equals 105. My variable x being multiplied by 6. So I'm going to divide by 6 on both sides. So x is going to equal 17.5, and they didn't give us units, so let's just write the word units. All right. Alrighty, so today we solved problems involving indirect measurements using shadow reckoning and surveying methods. I hope that video was helpful. Thank you. Bye.